In this experiment, we're going to investigate an alternating current at very low frequency so we can see the properties clearly. We'll use a signal generator to produce the alternating current and allow that to flow through a bulb with a voltmeter that can read positive and negative potential difference that are connected across it, and an oscilloscope that will show how the potential difference changes with time. The large controller on the signal generator allows us to increase and decrease the frequency of the alternating current. Switching on, we can see how the current flows in one direction and then changes to flow in the opposite direction. The bulb glows both with the current flowing one way and the other. The reading on the voltmeter is positive to the right and then negative to the left, continually changing from one way to the other. Increasing the frequency, you can see that the bulb flashes on and off more quickly, and the voltmeter reads positive and negative potential difference more quickly in time with the flashing of the bulb. If we increase the frequency further, the bulb flashes more quickly, but you can see that the hand of the voltmeter does not move as far as it did before. That's not because the potential difference is lower, but because the arm does not have time to move before the direction of the current has changed. Further increasing the frequency, the bulb now flashes so fast that it appears not to be flashing at all, and the voltmeter needle is not moving either, because the AC is now at such a high frequency the arm of the meter does not have time to move at all. Note that does not mean that the potential difference across the bulb is now zero, just that we're using the wrong instrument to measure it. The oscilloscope is designed to measure the potential difference of an alternating current. Here you can see the measured potential difference increasing, returning to zero, and then in the opposite direction, with the frequency matching the moving needle on the voltmeter. Increasing the frequency of the signal generator, you can see the trace on the oscilloscope change to show that higher frequency. Looking more closely at the oscilloscope screen, you can see that the peak and the trough on the screen matches the flash of the bulb. Increasing the frequency of the signal generator shows the increased frequency of the signal on the screen. Notice that the size of the peak and trough does not change, because the potential difference across the bulb remains the same even as the frequency changes. If the peaks and troughs on the display of the oscilloscope become too close together, remember that you can use the time base to alter this to make it easier to see.